Okay, everyone, here's the answers to the questions. There are 30 questions and there's going to be 1 mark for each question. This means you've got to answer each question correctly. There's no part marks. You've got to get all right, or if it's not all right, then you don't get the mark, okay? So the first one is 281. Second one is balance the chemical equation. You should have got a 2 in front of the lithium, a 2 in front of the H2O, and a 2 in front of the LiOH, the lithium hydroxide. If you're struggling with this, then find the video on the channel called Balancing Equations, have a watch of it. These links will take you along there, and that will help you to practice that. Practice is the key. Complete the table. Really important information here that we need to know. So the proton is in the nucleus. It has a mass of 1 and its charge. Make sure you put +1, not just 1, or not just plus, but +1. Neutrons are in the nucleus as well. Their mass is 1 and they have no charge. They are neutral. And electrons, they live in the energy level. Their mass is 1/1840 and the charge is -1. Again, you must have the minus and the 1 in order to get the mark for that. Definition of an isotope, 2 key parts to this. You need to say that they have the same number of protons but a different number of neutrons. Okay, make sure you've got both aspects mentioned so that you get the marks for that question. Okay. Right, a calculation to find the mass of an isotope. To do this, you take the percentage abundance, so in this case it's 19.9, and you divide it by a percent, which is 100, and multiply it by the relative atomic mass, which the first isotope is 10. You do the same for the second isotope, so it's 80/100 times 11. Work this out on your calculator and it gives you an answer of 10.8. As a little check, remember there's a greater abundance, 80.1%, with a mass of 11. That's the greater abundance. Therefore, I expect my answer to be nearer to 11 than it is to 10. Turning over, question 6. I need my pen to add a little bit to this one. So question 6 says draw before and after for beryllium oxide. So here is my beryllium electron configuration 2,2. Here's my oxygen electron configuration 2,6. What's going to happen is these electrons here are going to be transferred across, so this can become stable, and then this can become stable by having 8 electrons. Remember, electrons are negative, so if I lose electrons, if I lose negative charge, I will become positive, and if I gain negative charge, then I'm going to become negative. So you should have then got beryllium, because it's lost 2 electrons, becomes 2+. Remember, square brackets, and then a 2+. And the oxide, there's my 2 electrons it's gained, becomes a negatively charged ion, 2-. I just put in a little summary for you, if there's a little space in there to write an answer. So beryllium transfers 2 electrons to the oxygen. I guess I should explain that beryllium becomes a positive ion and the oxide becomes a negative ion. Why do ionic compounds have high melting and boiling points? This is because in their structure they have electrostatic attractions, and these are strong. Key phrase, they are strong and they need a lot of energy to break. You've got to say that they contain strong electrostatic attractions which need a lot of energy to break them. Okay, that's the first little bit. Let's carry on. So we're up to question 8. Let's turn this over. So question 8 is another table for you to do. So in question 8, it asks you to explain whether they will conduct electricity or not. So this is a solid sodium chloride, so it's a solid ionic compound. They do not conduct electricity because the ions are held in a lattice and are unable to move. We have to have those ions, those charged particles, free to move. The next two, I've been a bit lazy here, they both will conduct, and they both conduct for the same reason, because when we make it molten or when we dissolve it, the ionic lattice is broken, so the ions are free to move, the charged particles are free to move, and it will conduct electricity. Covalent bonding here, draw a molecule of water, H2O, showing the outer electrons only. So what I've used dots and cross diagrams here to help me see where they come from. So my crosses are the electrons for oxygen, and my dots are my hydrogens. So you can see here, here's my covalent bond to attach the oxygen and hydrogen, and here's another one to do the same. And then I've got 1, 2, 3, 4, 5, 6, 7, 8 electrons being shared by oxygen, so that's stable. Each of these are stable because they've got 2, so there is my molecule. Make sure you've got 2 electrons in the bonds each side, and then there's these electrons here that are not being used in bonding, but do then make the molecule stable. Question 10, talking about properties of covalent compounds. So explain why they have low melting and boiling points. That's because they have weak forces between the molecules, and because they are weak, they do not require a lot of energy to break. Why are simple covalent poor conductors? Because their electrons are used in bonding, as you've just seen here, and therefore they're not free to move, and it will not conduct electricity. Explain why graphite conducts electricity. Well, graphite is made from carbon, and in graphite each carbon contains 3 bonds. Now you should know that carbon wants to make 4 bonds. The fact it makes 3 means it's got a spare electron, and that electron can become delocalized and can move, and therefore will conduct electricity. Turning over, question 12. Question 12 says, why is diamond a hard material? Okay, so diamond has 4 bonds, and those 4 bonds mean that that structure is very rigid, so it's really hard to move it about, and therefore it is very strong, hard material. Explain why diamond and graphite have very high melting and boiling points. Anytime you see reference to high melting and boiling points, you know there is something strong in there that's going to take a lot of energy to break. So in this case, they both contain strong covalent bonds, and there's lots of them because these are macro molecular giant covalent compounds. So they contain lots of strong covalent bonds for the first part, and they need a lot of energy to break them for the second part. Okay, why do metals conduct electricity? You should know that they contain delocalized electrons, and the official term for these is a sea of delocalized electrons, and they are free to move, therefore allowing the metal to conduct electricity. Okay, some calculations. So calculate the relative formula mass for magnesium hydroxide. Watch out, a little trap in here. There is 1 magnesium, but be careful because there are 2 hydrogens and 2 oxygens. Okay, and that's why we know there's O, and we've got times it by 2, and H times by 2. So we need to double these up, and you should get an answer of 58 as the final answer. Make sure they always expect you to show your working out. Make sure you put your working out in. Okay, don't get sloppy. Question 16, how many moles are there? Okay, to work out the number of moles, we use our triangle, and the triangle says that number of moles is mass divided by mR. So the mass in this case is 24, because it asks us 24 grams. The mR, remember the mR is relative formula mass, so I take and do that little bit of thinking over here. It's CO2, 1 carbon, 2 oxygens. Work this out, so 1 times 12, 2 times 16, gives me a total, when you add it all up, of 44. So it's 24 divided by 44, which is 0.55 moles of carbon dioxide. Next question is calculate the number of atoms in 1.5 moles of iron. We've got to use Avogadro's constant. Remember, Avogadro's constant is the number of particles in 1 mole of a substance. Okay, so the way I can use this to find the number of atoms is the number of moles times Avogadro's constant. So in this case, it's 1.5 multiplied by Avogadro's constant, and that gets me 9.03 times 10 to the 23 atoms. Make sure you're confident in manipulating these this kind of information in standard form on your calculator. Definition for empirical formula. Empirical formula is the simplest ratio of the number and type of atoms or elements in a compound. Okay, simplest ratio. Let's have a look. We've done that one. Next one in. Okay, next one is number 19. 19 wants us to actually calculate the empirical formula. The steps to this, so make sure you follow the steps, get used to the routine. The key to learning this routine is just practice. Go and do lots and lots of these calculations. The first job is you write down the masses that we are given in the question. Then you write down the relative atomic mass, the MR, which is found on the periodic table, so 31 and 35.5. Then you divide these two numbers. Okay, so this 0.31 divided by 31 gives me 0.01, and 1.07 divided by 35.5 gives me 0.03. Divide these by the smallest number. So the smallest number here is this. Divide that by itself gives me 1. Divide this by 0.01 gives me 3. Therefore, my empirical formula is PCl3. Okay. This is a calculating reactant mass. Okay, 3 steps to do these. Get used to the routine. Again, if you're not sure, please go and practice it. Watch the videos. do lots and lots of questions, and you will get really confident with this type of question. So the first job is I always ask people to write down the information we know in the equation. So it tells me there's 50 grams of iron oxide, and we want to know how much iron it will make. Because I'm given the mass of this, I'm going to start with this and convert it into moles. So that to get the moles, you take the mass and divide it by the MR. The MR for iron oxide is 160. Remember, that's the mass of all the atoms added up. Divide that out in your calculator and you get 0.31 moles. Then we've got to use the stoichiometry, the ratio in the question. You can see here it goes from 1 mole of this makes 2 moles of iron. So I've got 1 to 2. I've just worked out I've got 0.31 moles of this. So I have to double that because this doubles. So I double that to get the number of moles of iron. And then I reuse my triangle, but in the other way around. So I now have the number of moles. I've got to find the mass. So the mass is the moles times MR. And we work this out and we get an answer of 34.7. Remember, this is kilograms, so it's going to be kilograms. 34.7 kilograms. And what's the difference between strong and weak acids? Strong acids fully dissociate, fully separate into the ions. Weak acids only partially dissociate. And what's the difference between a base and an alkali? Alkalis are soluble, bases are insoluble. And then some word equations here to do, and then turn them into symbol equations. So this is a neutralization reaction. So this is an acid and a base. An acid and base makes a salt and water. You need to know that. The salt depends on these chemicals you've got here. So nitric acid makes nitrates, and the first name lithium gives us the first name of the salt. So it's lithium nitrate plus water. Formulas, if you're struggling to work these out, ask me in class and I'll show you how to do this. And we'll practice getting good at that. But we have got HNO3, LiOH, LiNO3 and H2O, and that's actually a balanced equation, so that's correct for the mark. Okay, turning over, question 24. This one's a little bit more complicated because it's still a neutralization reaction, but it's asking me to do it for a carbonate. Carbonates, when they react with acids, you still get the salt, and you still get the water, but you also produce carbon dioxide because it's a carbonate. Okay, you can see here, once I've got the formulas written down, I do need to balance this equation by putting a 2 in front of the HCl, and this equation is then balanced. Describe this test for hydrogen. We collect the gas in a test tube, we put a lighted splint into it, and it will burn with a squeaky pop. Describe the chemical test for carbon dioxide. What we do is we bubble the gas through lime water, and the lime water will go cloudy. Got to have both steps in there for the marks. 2 reasons why electrodes are made from carbon. Carbon is inert. Inert means unreactive, and also it is able to conduct electricity because it has those delocalized electrons in the form of graphite. Half equations for the electrolysis of aluminium ions. So it's Al3+. 3+ means it needs to pick up 3 negative electrons to make aluminium. And as it says in the question, that is reduction because it's gaining electrons. This is a bit trickier, watch out for it. Oxygen is diatomic, so it's got to be O2. Therefore I need to release 4 electrons, and I need 2 lots of oxygen ions to make it work. And the final one, just checking, the final one here is complete the table for the electrolysis of copper chloride solution. Now remember, really important, copper chloride solution, AQ, means it's dissolved in water. This means we get copper ions and we get chloride ions from the ionic compound, but then we get hydrogen ions and hydroxide ions from the water. So we've actually got 4 lots of ions that we need to think about. At the cathode, the rule is that it's the least reactive cation that's going to react first. So in this case, the least reactive is the copper. So the copper is going to pick up 2 electrons because it's a 2+ ion to make copper. Gaining electrons is reduction, and that forms copper. On this side of the equation, the anode is the anions go. Here it's going to be the simplest that reacts first, so that's going to be my chloride. It's only got 1 part. This has got 2 parts, so the chloride reacts first. There's my equation. Chloride ions become chlorine by losing 2 electrons. Loss of electrons is oxidation, and we make chlorine. Okay. Hopefully that gives you the marks and the answers you need. It's out of 30. Transfer your marks onto the Google Forms that I've put there, and that will then come back to me, and I can use that to help identify where we have gaps in our work that we need to work on once we're all back together in school. And I'm really looking forward to seeing you either towards the end of this week or next week when we're all back together. Take care, everyone. Bye bye.